Homework 3.3, Polynomial Division, Factor Theorem, and Remainder Theorem. Video 3, homework due Wednesday, May 27th, 2020 at 11:59 p.m. This video is associated with question 5 in homework 3.3. And as I said in the previous video, the first 5 questions in the homework are all just long division problems. Some of them have certain issues, and that's why I'm being very specific about the problem number. I bet you can figure out what the issue on this one is based on the title. Sometimes when you're doing a polynomial division problem, the dividend, the divisor, or possibly both might be missing some terms. Now, what do I mean by missing terms? Well, normally when you see a polynomial, it starts with the highest power of x, or whatever the variable is, and then you expect to see every lower power below that following it. For example, if I see an x to the 4th, I expect the next term to be an x to the 3rd, followed by x to the 2nd, followed by x to the 1st, followed by a constant term. This one just suddenly stopped. X to the 4th, x to the 3rd, x to the 2nd. Where's the x to the 1st, and where's the constant term? And it's not the only one missing a term. Look at the divisor, the 2x squared plus 1. It's a second degree polynomial because its highest power is 2, but after x squared, I usually see an x term, and there's not one here. So what happens if either the dividend or the divisor or both are missing some terms? Well, watch what happens if we try to just jump into this. Let's set up the division house. And I don't actually know the name of this division house symbol because, well, I've looked for it, I've researched it, but I can't find a name for it. Vinculum is not the correct name. Somebody brought that up to me once, but that's the name of the bar you put over a repeating decimal. So I just call it a division house. So our dividend is 12x to the 4th plus 14x to the 3rd plus 2x to the 2nd, and our divisor is 2x to the 2nd plus 1. If you try to jump into a long division problem with missing terms, watch what happens. How many times does 2x squared go into 12x to the 4th? Well, let's just think about it. If we put the 12x to the 4th on top of the 2x squared, 12 divided by 2 is 6. X to the 4th divided by x squared, I would subtract the powers and get x squared. I know I didn't put the 6x squared over the squared term, but the truth is it doesn't matter where you write the terms in the quotient. If we multiply, 6x squared times 2x squared is 12x to the 4th, which we expected. But 6x squared times positive 1 is positive 6x squared. And now we get a slight problem. These aren't like terms. If you're thinking, I'll just write it over there, that's not necessarily wrong. But when you are missing terms in either the dividend or the divisor, you will have some misalignment of terms. So you can either be very careful or don't have any missing terms. Now, what do I mean by don't have any missing terms? I can't control what's in the polynomial. The problem's given to me as is. How do you expect me to write something that's not there? Well, how many x's are in the middle of this? I don't see any, do you? Me neither, because their coefficient is 0. Any missing term can be represented with the 0 coefficient. Any missing term can be represented with a 0 coefficient. So in other words, when you go to write a term and it's not there, just write it with a coefficient of plus 0. So if I were to set this one up, let me start with the divisor. 2x squared, I'm expecting to see the x term, it's not there, so I can represent it with a plus 0x and then the plus 1. And I can do the same thing with the dividend, which doesn't look like it's missing any terms, but the powers have to go all the way down from the largest down to no x's at all. So we do have a 12x to the 4th, and we do have a 14x to the 3rd positive, and we do have a positive 2x squared. But there are no x terms, and there is no constant term at the end. I know it makes the problem longer, but it guarantees that all like terms will line up. Now I'm going to go through this division problem a little faster than the first two, since I'm not really teaching the technique of long division in this example, but rather illustrating that if there are missing terms, you should represent them with the 0 coefficient. But I invite you to pause the video and attempt the long division, and then come back and see the results. But I'm going to go through it at my speed, actually slower than I normally would. How many times does 2x squared go into 12x to the fourth? Well, 12 divided by 2 is 6. X to the fourth divided by x squared is x squared. I know, I lined it up. Sometimes I do, sometimes I don't. Now we multiply 6x squared times all of this. 6x squared times 2x squared is 12x to the fourth. 6x squared times 0x is 0x cubed. 6 times 0 is 0, x squared times x is x cubed. And 6x squared times positive 1 is positive 6x squared. Time to subtract. So it's time to change all the signs and combine. So the 12 becomes negative, the 0 becomes negative, it's 0. And the 6 becomes negative. The 12x to the fourths cancel. That was supposed to happen. If that doesn't happen, something went wrong. 14x cubed minus 0x cubed is still 14x cubed. And positive 2x squared and negative 6x squared is negative 4x squared. Bring down the next term. And do it again. How many times does 2x squared go into 14x cubed? 14 divided by 2 is 7, more specifically positive 7. X cubed divided by x squared is x to the first. And now we multiply everything over here by 7x. 7x times 2x squared is 14x to the third. Not a surprise there. 7x times 0x is 0x squared. It's still 0, but like terms. 7x times positive 1 is positive 7x. Time to subtract, or more specifically, change signs and combine. 14 becomes negative, 0 becomes negative. I get a kick out of that because 0 is technically neither positive nor negative. And the 7 becomes negative. The 14x cubes cancel, that is expected. Negative 4x squared minus 0x squared is still negative 4x squared. Positive 0x and negative 7x is negative 7x. And bring down the last term. Here we go. How many times does 2x squared go into negative 4x squared? Well, negative 4 divided by 2 is negative 2. X squared divided by x squared, the x's would cancel. Last term of the quotient is negative 2. Negative 2 times all this. Negative 2 times 4x squared is negative 2 times 2x squared is negative 4x squared. Negative 2 times 0x is still positive or negative 0x, but it's 0. It really doesn't matter as long as it stays 0. Negative 2 times positive 1 is negative 2. Time to change the signs. Negative 4 becomes positive. Positive 0 becomes negative. Negative 2 becomes positive. 4x squareds cancel. That was supposed to happen. Negative 7x and negative 0x is negative 7x. And 0 plus 2 is plus 2. We're out of terms, so we're done with the division. And you may be wondering, why is the remainder not just a number? Because we divided by a larger degree polynomial. You know we're done when the power here gets below the power here. So our remainder is a little chunkier. It's negative 7x plus 2. It goes on top of the divisor, and the original divisor was 2x squared plus 1. There's no need to represent missing terms in the answer because we're not trying to preserve the alignment of like terms. So when you divide by a bigger, chunkier divisor, nothing changes. You just have to proceed more cautiously. In the next videos, I'm going to show you a quicker way to do some division problems, and it's so quick you're probably going to never want to do long division again.